Okay. For people who are joining this live stream, we are reviewing some of the new image, audio, and signal processing functionality for a future version of Wolfram Language. So this is kind of a long list of things here, which is good. All right, let's start off. Image contents, image cases. So we met fairly recently about that, right? Shadi?
In the machine learning meeting, we have talked about this. As you know, we would still like to retrain these networks. We've been working with the curation team to get some consistency between the labels and the classes of some new data sets we're using and the old ones. We are ready to train very soon.
Okay. And what are we doing with this image pattern object business?
That's not yet planned, I think, for 12. No. That we are
okay. So image cases, it will be pre-trained categories of thing, but it will not yet be find an example of this thing, train and find an example. Is that true?
Correct.
I thought we did have a chance to do that. Can you check on that, please? Because
Sure.
I think that's not impossible. My understanding from that meeting was that was looking, possible. What do you think, Roger, about image position versus image positions, plural?
Well, I mean, it's not that big a deal either way.
Well, except that there's a consistency issue.
No, I realize position is what you're thinking of, right?
Yeah. I think we should probably call it image position. And just say gives the position, what do we say for position here? I think it's okay. We should just call it image position. Shadi, is that okay with you?
Yep.
So with image contains queue, that is analogous. I mean, that's analogous to member queue in some sense. Is that right?
Yes.
But I think it's utterly obscure to call it member queue. And we do have some contains type stuff, right? Do we have text contains queue? String contains queue for sure.
Contains
Fine.
any, contains only. Yeah, we have a family of some functions with contains. Contains structure queue.
Yeah, okay. Well, fair enough. Okay. All right, let's go on because I want to get through this whole agenda and we'll go back on some of these later.
Yeah. You're likely to want another meeting.
Yeah, on this stuff for sure. Once that's basically running, I want to try it out.
Sure.
Makes sense? Because I think there are going to be some settings there. I think we may have to tweak some things about specificity, thresholds, etc. For things like image cases. Because, what if there's what if you have a picture and there's a few pixels and it thinks it might be an owl in the tree, right? How do we deal with that? We have a question on the live stream about image cases retraining. No, the retraining is just something we're doing once and for all from our curated data. It's not something that will rehappen. Unless you're using the image pattern, which I guess still needs some design, because that probably will require training once and for all. Right? Image pattern object would do the training, presumably. So that then the pattern object, once it has been cooked, will be available pre-trained to use. Correct?
Yeah, that's the ideal goal.
Okay. Okay, find faces, good things happening. Okay, face recognize. Now, what is that going to do? Do we have a page for that?
Yeah.
So given a list of faces, Okay, so that's a single example of a given face, right? Like something from the employee directory or something.
Yep.
Is that right?
Yes.
And that's if you want to have multiple examples here.
Correct.
I don't
In the
quite
first
understand
syntax,
this.
you could also have multiple names or the same name on the right-hand side. So you could have multiple examples for the first name. That's just two different syntaxes.
I see.
Just like
Okay.
classify.
Okay, fine.
And then that third syntax, you either get the same first argument in the same form in one of the two previous
Or you have a classifier
inputs.
object.
Exactly.
Classifier function, yeah, okay. I don't really like this. I don't like using that pun of having the, training in italics there. It would be good to reword that.
Yep.
Okay. But now here, what you typically get out, the default, yeah, okay. By default, the list of names associated with all recognized faces. Face recognize gives a list of names associated with faces it recognizes or something. Is that right?
Correct.
Okay. Okay, that's wonderful. Does it work?
The one arc form is not in the builds, that it returns classifier function.
Why does it need a method there?
It shouldn't eventually, yeah. That's the current version in development that needs that syntax.
Okay. So is this correct? I can't see the picture well enough to see. Is this correct or is this... Okay. Very nice. Isn't that Clinton there?
Yes.
But so it didn't get that one.
It didn't get it, right? Because the face that is in the training in the first argument is a frontal face.
Right.
And you can't get that with one
I think that's a confusing example to give. I think that's confusing. I think you should give that as like a second example, but the first example, it should just nail it.
Okay, sure. I'm actually, now that you say it, unsure of the copyright of that example. I'll have to check that as well.
Okay. Okay, acceptance threshold. Did we go over that already?
No.
Didn't we have a long discussion in the machine learning meeting about this?
I think not the machine learning discussion or meeting. It was the anomaly detection meeting with Etienne and Amir.
Fine. So this is the same acceptance threshold, right?
Yes.
Okay.
I just I asked Etienne whether he's gonna document it with you or not. Didn't get a response. This is my draft of the page.
Okay. I mean, it looks okay, but you should check it with Etienne.
Sure, I will.
Sorting function. That could be used for many, many, many things.
Right. You should probably also open find faces. This is...
Okay, but find, I mean, that sorting function is also relevant to image cases. It's also relevant to text search.
Yep.
What are we doing for text search? I thought we already had something like that for text search.
Yes. This was sorting function page existed in CVS before.
I see. Okay, so there is a sorting function option here, but it hasn't been activated.
Exactly. Right. And then
so
all the notes you see below the page for sorting function are your old or Chiara's old notes. I repurposed that page that was already in CVS to be generalized and then usable for find faces.
Fine. What the hell does that mean? specifies a function to apply to sort the results of a computation.
Yep.
But in particular, this has impact, right? If you want the 10 first.
Well, no. 10 first is, what do you mean 10 first? You mean 1, 0 first, or what are you saying?
If you sort it, so it's ordered in some way.
I see, I get it. But now, is this a sort by? Do you understand what I'm asking? I think it's a sort by.
It is,
right?
Basically, yes.
Yeah.
Specifies a function. A function to use to sort the results of a computation by. Specifies of the function by which to sort. Okay.
The result of a computation?
No, I don't think so. I think what we want to say, sorting function, at some point here we need to say sorting function arrow F effectively gives sort by list comma F, right?
Yes.
Okay. All right, I understand, and this is good, but please make sure that the other places that the other folks get contacted about this.
Sure.
Okay. Yeah, I mean, it's basically things where I'm wondering if there are also some things involving file systems where there also isn't a well-defined order. It's things where there isn't a well-defined order, but where we have to impose an order. Is that what I'm saying? I mean, I wonder, I could imagine functions like find instance needing this as well. Roger?
Maybe, if you find multiple instances, you mean?
Yeah. 10 instances of a triple or something.
I don't think it's not like that, They're really, it's not like a big set and then you sort. It's like you construct exactly what you need.
Okay. All right. Okay. Are there geometric situations in which this comes up with, and what about, there might, okay, GeoNearest doesn't have this because it's sorted by nearest distance. I'm
guessing search functions, web image search, if you have web audio search and so forth, as long as the APIs we use allow for sorting.
I don't think they allow. That's a good question to raise. I don't think they allow for very much sorting. They only allow for the sorting within the gulp that we already took, if you understand what I'm saying.
Yep.
But you should contact the Service Connect folk about that.
Sure.
Okay, let us go on. And I'm going to let you sort out the remainder of this page. Fair?
Okay.
And you should contact Chiara about what happens with text search there.
Sure.
Okay, next up, color. Image color, what is that? Image recolor, sorry, what is that?
That is, if you want to, yeah.
Okay.
That's kind of the useful version of changing color.
Okay. In the region specified, so it has a mask, is that right?
The region of interest can be specified as a color, like in that first example, it's yellow. So it finds the yellow region, but you can give it an explicit mask as well. Or you can give it that color neighborhood wrapper we are introducing in 12 that says colors within the 0.5 distance from that blue.
Okay, let's talk about that name. Okay, so that is the analog of interval, is that right? Or it's the analog of number with uncertainty, otherwise known as a round.
Mm-hmm.
I wonder if it should say color around.
No, I mean, it's not anything to do with statistics. It's just everything that's within that.
Yeah, it's a ball with respect to some metric.
Yeah.
Yes.
And can you specify the color space to give the metric?
You can specify the color distance.
Which has a metric in it, like it could be XYZ color or something like that.
Yeah. The useful ones are Euclidean and LAB, and then some variations of that.
Euclidean and RGB space is what you mean.
No, LAB. It needs to be a sort of perceptive color space, Stephen, or it will be very...
No, I understand that. But so you're saying the default is LAB space, is that right?
Yes.
Okay, fine. An LAB space is a 0-1 type space or not?
No.
In other words, what is that?
You mean the distance? No, yeah. It goes beyond. L is 0-1, A and B are negative, typically 1 point something to 1 point. It's
okay, fine, but it's of order 1. It's not 100, for example.
Exactly.
What I'm thinking about, Roger, is what should we have this for numbers?
What would it be for a neighborhood? You mean just neighborhood?
Yeah. I mean, in other words, what is the relationship between neighborhood and around? Now, around
is intimately tied to statistical.
I understand, but neighborhood is kind of the uniform, the hard disk version of around, if you understand what I'm saying.
Yeah. I mean, we do have intervals, but our intervals are not sort of center radius spec, which is another way to do it.
Yeah, I understand. But then these are also multidimensional.
Yes. I don't see the immediate, I mean, we probably will get to that. And now in another review later, Stephen, we'll be talking about vector inequalities a lot.
This might be highly relevant.
Well, I'm just saying that we're getting a lot of constructs that are sort of high dimensional, for all kinds of things in the language.
Yes.
So.
Well, good, but I'm for some reason, color neighborhood. Are there any alternate possible names for this?
We had a bunch we thought of.
Originally, we had color range, I think.
I don't like that. That suggests it returns something.
Yeah.
Color disk. Not really.
We had a color region even.
Color region, right.
But it's not a region. That's the problem.
Because it could be a region, but it's not.
No. It's effectively a mask that it gets translated to.
A mask in color space.
No, a mask in the image space.
Yeah.
I don't understand that comment. I mean, this is representing a color. So if I say color neighborhood, I mean, I'll get a color. It will come back as color neighborhood of a swatch, D. But if I then say chromaticity plot of color neighborhood, what will it look like?
It should do something like what you see in that plot. It's not supported yet, but it should probably just draw outlines like what you have in that illustration.
But I don't understand those. I mean, what it should do is probably just highlight. It should probably just make a gray quotes disk, although it won't be circular, in whatever color space you're displaying, right?
Right.
Is it the case that the LAB RGB color transformation is like not it doesn't disconnect, right? It is still a disk. It is still topologically a disk in RGB color space if it is a disk in LAB color space. True?
Should be.
Okay. There's something funky.
We'll have to verify that.
It's a good concept. It is a good concept. All right. Find matching color. What's it going to return? Okay, so it finds the red in that image.
Exactly.
This is not quite English. Looks into the dominant colors. Find matching color. Please don't use doesn't. We don't do that. Does not. I'll change that. Just not the style we use here.
Okay.
I don't think you should say that it looks at dominant colors. I mean, are you saying that it is that it always uses the dominant colors thing?
There is this note. We could take it literal and say that we are looking into what dominant colors returns, but also conceptually, what happens if you have a single pixel that is red? It doesn't get returned because
I see. Considers the dominant colors. Takes the dominant colors of the image and returns any color a color it finds close to color.
Yes.
Okay. Max color distance. It's kind of annoying that we have to have. Is this an old option?
Yes.
Wow. I did not know about it. Okay. Are these old options? Min color distance?
Yeah.
Wow. I didn't know about those. I haven't ever dug into dominant colors. I just use the default.
Good, it worked all the time.
Yes, I didn't have to have a look. That's good because it is quite slow. Dominant colors has been quite slow.
Yeah.
Color quantize. By the way, there was a very good kid at the summer camp this year who implemented a bunch of color dithering algorithms. And that's, I mean, we are using dithering for color quantize. Is that right? Or
yes.
what?
We don't have we just have one algorithm implemented. I'm aware there are more.
It just implemented a whole bunch of algorithms.
Okay.
Hopefully he's going to continue to be involved with us. You can contact probably Swede would have the information, or Andrea Griffin.
Okay.
And you can also just look at the summer camp Tumblr, and you'll find the thing about dithering. It's quite a nice piece of work, actually. Okay. One argument form.
Color quantize, you always had to provide how many colors you want to quantize to. We would like to be able to just guess how many.
I agree. Okay, image demosaic. What's that about?
It's an older function, version 9, I believe, and it needs a lot of updates. I'm still waiting to wrap up development to see whether it can make it to 12 or no. Summary, we're going to have hopefully some more algorithms. We're going to make...
What does it even do?
It's the sensor data that comes in, and you convert that to an RGB image or a color image.
Can we please, if we're going to use this function, can we please put it in the spelling dictionary?
I'll email.
What does it do again?
From cameras, you get raw images back that are single channel. You get the SSD data, right?
Yeah.
The sensor data. Image demosaicing is the process of converting that raw data into RGB data. Typically, you have patterns like that RGB pattern. So you have half of the pixels.
Oh, I see. This is the truly raw image, exactly. Which we automatically, when we do import, we are converting it, are we not?
Yes.
Okay, so this is, if it does import of a raw. Okay, so if you do import on a raw format, is there an import element that gives you this pure pixel by pixel, what the CCD sees type version?
Yes. It's raw image or raw data versus data or image.
So hopefully you can show that in the example here of demosaic.
Right.
Okay. And hopefully this has some reasonable keywords that would actually allow me to find this, because I would never know.
I'll update that.
I would talk about things like CCD array. In fact, I'm even going to add CCD array. Even color sensor array. I don't know. Lots of other things like that.
You could probably list cameras and raw formats and so forth.
Yes, that would be good too. Whatever. Okay, all right, let's keep going. Microscopy.
It's a guide page, Stephen.
What the heck? Okay. So there are new things here or what?
No, just a guide page.
Is this a new guide page?
Yes.
I think the title is a little weird, hard to understand. Why don't we call it computational microscopy or something? Let's object to that. I think the word microscopy has to be in there rather than microscope.
We probably need to add a lot more to something like computational microscopy, other than just processing.
Well, then image processing for microscopy. I just think microscope image processing. Microscope can be a verb in modern times, and it's super confusing. Roger?
Yeah, I think that sounds good. Image processing for microscope.
No, I'm suggesting image processing
for microscopy.
Microscopy.
I think then this sets the tone nicely for a bunch of other image processing for XXX.
I agree. Unless we want to say image computation for microscopy.
Would be more correct, as we do a lot of analysis as well.
Why are we really listening? I mean, if it's a microscope, why are we doing web image search? I mean, that's a very sort of secondary thing.
I agree. We can probably remove it.
Is current image, I mean, well, does current image work if you've connected a microscope? If so, it should say that.
Microscope.
So you should say that here. You should make that a separate line here, because that might be super useful to people. And again, I can't say, I mean, if that's important to microscopy, and by the way, this is following that ... doesn't come with a link there, and it should if it's going to be a ... Well, there's a lot of interesting stuff here. I mean, obviously, image cases will be of high interest here.
Mm-hmm.
Okay, fine thing. Okay, image type. I have no opinion about this. What is this one?
Among the documented types for image and audio, we had real, which was representing real 64 for a while. With the numeric array updates and others, we decided to be explicit. We always supported both real and real 64 when constructing.
Fine.
This is the only place that is going to be backwards incompatible. And we are now returning real 64.
Well, hopefully there aren't too many places where people have done a test.
Right.
You might look at our code base and see if there are.
We have done that. This change has been in prototype for a long time.
Okay. Dynamic image. Oh boy, haven't we seen this creature before, this image pyramid thing before?
Yes.
I have no opinion about it. What is the point of this thing, really?
For related to dynamic image, this is going to be a fast, efficient way of accessing the image at different resolutions. So we compute different resolutions once, and then as we zoom and pan, we just use the level that we need.
Why isn't it an image pyramid function here?
It will be. You mean the return? The result is going to be an image pyramid. Yeah, the data is going to go away.
Okay, so what is it going to become? Just image pyramid, or is it going to become a separate image pyramid function?
It's going to be an image pyramid. So image pyramid is going to be both the constructor and the container.
Okay. So image pyramid, this thing either curried of 7 or something, or comma 7. What would comma 7 give you? Does it give you a list up to 7, or does it give you just the nth level? I see.
The nth level.
The Gaussian pyramid? I think that's whatever this is. Look, honestly, this is a fairly obscure function. And I would almost consider calling it something like image multi-resolution pyramid or something. Because otherwise you see image pyramid in a random piece of code, and it's like, is this an ancient Egyptian invasion or something? Am I making sense?
Yeah, it's been always very intuitive to me what it is, but I see your point.
Yeah. I mean, why not call it image multi-resolution pyramid or something? Or image... What is its full name?
You see that it can also contain the difference pyramid, right? When you specify the pyramid type in that illustration, you could have the multi-resolution image, which is the Gaussian pyramid, or you could have the Laplacian pyramid. And then there are various other methods, including one that we've included, Reese's.
Is this really the right thing here? I mean, this is really it is another form of... Okay, what would happen if I wanted an image represented by an octree or something, or a quad tree, rather?
It's sort of a simplified wavelet.
But I mean, if I wanted I notice Philip's on our live stream saying that this thing is used a lot in vision research, and he has a dozen implementations, mainly of Gaussian pyramids. That's interesting. Okay, but I'm just trying to understand, if I was going to give a quad tree representation of this image instead, for instance, isn't that another way of giving sort of a multi-resolution version?
No. Why not? Quad trees and octrees are used for geometric search, and they.
Yeah, what if I go down to a certain level? Isn't there a version where I guess it's not as useful as this? Well, whatever. Maybe I'm just confused. But I mean, if I go down and I say, I'm imagining something where there's meshing down to a certain level, right? And where some parts of the image are just shown at only level 4 or something, which is a big blob, and some parts are shown at level 8 where it's much finer. Right, like a mesh that's been refined in some places.
No, I got it. But it's octrees and quad trees. It's this geometric data structure, but it's not used for. It's used for geometric search. It's used to locate things quickly by avoiding.
No, I understand that, but I mean, okay. What is this thing? How does this thing actually work? What does it do?
Look at a few application examples.
I think if you look at fusion or removing noise at different levels, or
what are you doing here? I don't understand these examples.
The first one was finding lines at different scales. The second one is blending two images at different resolutions.
I see. But so I guess I'm still a little confused here about what you actually do. So one issue is...
The thing is that you build the pyramid, okay? And then you can decide that you want to, let's say, for instance, you want to apply a filter at one of the levels. That tells you sort of how fine you do it, So some things are very visible at low level, some at very high level.
Yes.
And you can also combine two different stacks. That was the fusion or blending case down there.
Okay. Philip's comments that image pyramid is a generic object. The contents at each level of the pyramid are specific, i.e. Gaussians, Laplacians, differences, etc. I don't quite understand that comment. So in other words, the question of whether you extract Laplacian is a subsequent decision. Is that right? It's not the nature of the pyramid itself. It is merely what the pyramid outputs.
Well, I think you can reconstruct the image from the Laplacians just as you can from the Gaussians.
But the Laplacian is what gets stored in the pyramid,
right?
Not what the pyramid returns. So if you look at the now I'm confused. Laplacian pyramid, the top level, that level 4 there, is not a difference anymore. That's just a low resolution image similar to what you have in the Gaussian. And if you want a reconstruction of a Gaussian pyramid, is just a resampling of, or just extracting one of those levels. But reconstruction of the Laplacian pyramid is upsample, add the details, upsample, add the details, until you get to the resolution you want.
Right. I noticed on our live stream more comments about people saying that this is useful. Nonlinear image registration. Okay, so I just want to make sure, because I don't fully understand this, I just want to make sure that we're packaging this correctly. In other words, if somebody wants to use this it's sounding like this is something where you often want to get level such and such of the pyramid to do things at. Is that right? Or am I confused? Or is it something where you will simultaneously operate at all levels in some way?
Both, I would say.
Okay, what's an example of a case where you would, so I understand, you go to level 2 or something, and I'm not quite sure why that's different from just blurring the image in some way, or downsampling the image in some way.
So that example, we're going to have an immediate use for it in dynamic image. As I said, it's just everything pre-computed. You have it, you access the right resolution at the right time.
I get that, but I guess what I'm asking is, what's the difference between, in the case where you're doing, let's see, these are these powers of 2 levels of downsampling or what?
That's yeah, by default, but you have the scaling factor in the 4th argument.
I see. Okay. But so what I'm trying to understand, okay, so look, first point, how analogous, so wavelets, for example, have not been a big success for us. And I don't really understand the notion of operations on waveletted things, if you understand what I'm saying. For a Fourier series, I understand, a Fourier transform, I understand you go to the frequency domain, you operate on it, you go back.
Yeah. We sort of do that for wavelets too.
No, I understand that. But in this case, you're not doing that because this is not this is a different kind of creature.
No, you kind of do that here too. Some of the applications, if you look at those applications.
We have also that inverse image pyramid that you may have missed.
Well, I saw that, yeah. Flip Phillips wants to get a copy of this right away. Good. Always a good sign. And it's commenting also that in computer graphics, texture maps have been stored this way since the 1980s.
That's right.
Okay, but so this is extremely encouraging that people are interested in this functionality. I still want to understand whether it's packaged correctly. So the way this works, if I'm understanding you, is image pyramid. So you say returns all levels. Does it return a list or no? It returns a function. It returns itself as a packaged thing, which can then be curried onto. I don't understand this at all, because the curried, it can be curried onto n to get the nth level. Is that correct?
Yes.
Okay. And that size, I wish you wouldn't do this, given size. I wish you wouldn't do this thing of doing this pun of having the italic thing be used as the name, if you get what I'm saying. It should say given to a given number of pixels specified by size or something.
Mm-hmm.
Anyway, okay, but the thing I'm trying to understand is, given this packaged image pyramid function effectively, which here you can extract level n from. What else do you do with it?
So there's another function called image pyramid apply.
Oh. Okay, this is where things start to get more complicated. Okay, fine. Modify images. Why isn't it called image pyramid map?
Because we have image apply instead of image map.
I see. I'd like
because
to know.
Of the confusion with map images, geographic map.
Right, okay. So applies F as a gulp to all images. So it's not applying to pixels like image apply applies to pixels, right?
Correct.
So it could have a different name and perhaps should have a different name. It's not applying to pixels. It's applying to each image in the pyramid.
Correct.
And what would that function, what kind of function would you typically apply to each image in the pyramid?
One example we had was that gradient filter computation. Another one that we had was the split assemble.
Okay, but the image, the gradient computation gives you kind of lines and thickened lines and so on.
Mm-hmm.
And then what do? You composite them all together to get where any line of any thickness is?
Yes.
Okay. I'm not buying the apply word here because I think it's different from image apply. And it's useful to make that distinction. And I'm confused about why. Oh, I see. Because image pyramid. Okay, so let's just go through this again. Image pyramid is returning an image pyramid object, basically.
Yes.
Although it's a self, it's a kind of self-representing creature. And that thing can be carried onto an integer to give that particular level, to give an image, a plain image at that level of the image pyramid. Is that correct?
Correct.
Okay. Meanwhile, you can take the whole image pyramid object and map doesn't work on it. I mean, why is it useful? Well, okay, all right, okay. But why is it useful to have an image pyramid object rather than just to have a list of the images at the levels of the pyramid where you can extract the nth element of it and so on?
It's just so that we don't have to keep track of the pyramid type and the scaling factor, possibly the padding value used and things like that, all the details.
Okay.
Everything is stored in the object.
Okay, so inverse image pyramid, how does it recompose it? Because I mean, it might disagree. I mean, I might have turned one level green and one level purple, right? What would it do in that case? Do you see what I'm saying?
I didn't get your example.
So let's imagine that I took the levels in the image pyramid. I made the top one red, the second one, level 2 red, level 3 purple. And then I say inverse image pyramid. Presumably that is attempting to reconstruct a single image from that, right?
Mm-hmm.
Okay, what does it do if there's incompatibility between the levels?
Well, I guess still if you have the Gaussian pyramid, what happens is that if you want to extract something at the size of, say, 1,000 by 1,000 pixel, it looks for the image at that size or larger than that, the first image larger than that, and then resamples back to the requested size. So if that ends up being the red image, you get a red result back. And then if the resolution is lower than the purple image, you get the purple image back. Currently, we're not doing any content check for the images. We do check that the pyramid has the right image dimensions and compatible color spaces and things like that across all images stored in the pyramid, but we don't do any content check.
Looks to me like Flip Phillips is quite an expert in this area. And it might be worth having a conversation with him offline here. Because I'm a little concerned about these He's talking about pyramid-based algorithms. And I don't quite understand what. I mean, the basic idea would be you're going into pyramid space effectively, just like you go into Fourier space. You're doing something there and then you're coming back. Is that right? But I'm confused about what. Right. I'm a little confused about how that really works. And I'm confused about what the analog, I mean, in the wavelet case, we have, I mean, the wavelets, it's sort of an orthogonal collection of things that you get, whereas here, the successive levels of the pyramid have no orthogonality. Am I making sense? All right, I think you guys should reach out to Flip and try and make sure that we're, I mean, unless, yeah, please. All right, I just want to have a quick look through here because we're over time for this. Dynamic image is still experimental, right?
Yes.
I mean, is dynamic image, so dynamic image comes from something outside of the notebook, true or not true? In other words,
the content of it?
Yeah, the content.
It could actually be either a path to a file or an actual image in the kernel.
Okay. Okay. But in the case where it's a file, I'm concerned about the management of that. Okay, because I mean, the issue is what happens. I mean, it's just like our same issue with data set and with these other, and with audio and so on, where we're now having that footer that says, do you want to include it with the notebook?
Right. I think that would be useful for dynamic image as well. But maybe at some point, well, scary if the image is too big.
Well, I understand. And I think what we're ultimately going for is the notebook bundle, where we can manage that a little bit better. But I think we don't want a situation where people are routinely having dynamic images and they're just going off into la la land. Mm-hmm. I mean, now, I assume, is there any meaningful way that a dynamic image can run against the cloud? Presumably it can, structurally. I mean, there's nothing that stops it doing that. And if you use the local cache function, it will cache into a local object on your machine as needed.
Mm-hmm.
Will that just work?
So you're thinking of of dynamic image itself, uploading to a cloud object, and then keeping that as a reference, as a backup reference.
Yeah, that's what I'm saying. I'm saying that way, because that way, if it's a public cloud object, people can access it.
One thing we've been thinking about audio, out of core audio, is to be able to interactively and programmatically do these kinds of storage location specification. You have a local file, you want to store it on the cloud. There might be a button, there might be a programmatic way.
Okay, so listen, there's a whole structure for this. It's the whole persistent value structure that we just built. Do you know about this stuff?
Some, not recently.
Okay, so let me just show you something. Like persistence location, there's this whole giant list of persistence locations where things can be persisted. Mm-hmm. Within a kernel session, notebook, local shared, cloud, and then there are these things like cookie managed and so on. Right? So this is probably the way to do it, is to use persistent value in some fashion. Or to use similar persistence locations, because that's really the issue, is how persistent do you want it to be? Flip is saying on our live stream that he'd be happy to chat. Thank you. Okay. All right. I don't think we're going to get to the stuff today, but let me just have a quick look ahead here. Speech recognize. How is that doing?
It hasn't changed due to the summer school. compared to what you've seen last month.
But structurally it was working, right?
Yes.
The people who were working on Speech Recognize were not at the summer school, so that's not an excuse I'm really going to buy into. Pitch Recognize, okay. Was that? I don't understand that comment, because Speech Recognize is being worked on by people who had nothing to do with the summer school.
Actually, you're right, but still no updates on that. It's still the matter of speed and some interval detection for the words.
I don't like frequency range as being an option for Pitch Recognize. Frequency range is too generic a term. That should be something like a loud frequency range or something. Am I making sense?
Okay.
Because frequency range could be something where you're asking, what is the frequency range of this stuff, and so on.
Mm-hmm.
Can I just try? I just want to try this because I think it's cool. Okay, so if I say audio capture and, oh, for God's sake, can I do this anyway?
Well, give it a try. I hadn't seen this before. Sorry.
Hello, hello, hello. Dead in the water.
No.
Will this work in the non-prototype build?
Pitch Recognize is not there.
No. Speech Recognize. Is Speech Recognize there?
No, none of them are merged into master.
Okay. Do we have example data that has some interesting...
Look for audio instead of sound.
Or do we have one small step or whatever?
That one we have a male voice and a female voice as well.
Okay, so let's try this one, for example. So this is example data. Okay, so this is hopefully going to be some audio. Why is this taking forever? Why is this doing this? Sigh. Okay.
I'll look into it.
Something broken in the prototype build. And that xCloud
that should work, right? That's a device update. I have seen that before.
Okay. So if I say Speech Recognize here of that, right?
Yep.
It's going to go grind, grind, grind. Is it going to give me any... It would be nice if this is really going to take a long time. Is it going to take a long time, or is it just loading something?
I'm guessing once things are loaded, right? It's downloading now. It should be in the matter of seconds for this 10 or so seconds audio.
What's it doing there? What, it downloaded 2 neural nets?
Yes, one for speech recognition itself, one for... a
language model.
Exactly.
Okay, let's just see what this does.
Oh, yes, sorry. Yeah, neural network framework still has issues in today's prototype build.
Okay, fine. Oh, well, would have been nice to see. Okay. Okay. This RLE thing, there was a crazy correspondence with Ed Pegg about that and its use for Golly.
Mm-hmm.
We probably should talk about that separately. All right, so we need at least another hour for all of this stuff.
Yep. Eric, is Eric here? Or?
I don't know. All right, anyway, this is looking great. Let's look forward to seeing the next round.
Okay.
Thanks to folks on the live stream, and talk to you all soon.